Roblox just released something very interesting for 3D AI community. I'm talking CubePart. It's not another local model that generates 3D, but it does understand what parts it consists of. It works like that. You can give it a 3D object and list of part names, and it will accurately extract them, like wheel, body, chair, legs, head, and it really works. You get separated nice 3D meshes. This is a big deal because most of 3D AI just give you one solid mesh that is hard to work with, hard to rig, hard to animate. And that means we're about to test it right now. I already installed it locally. I did some tests, I compared with another segmentation model and more in this video. So what actually mean understand parts? So let me first introduce you in more details what it is about. So CubePart is evolution of Cube 3D from Roblox, which is released like a year ago. And that's a model that Roblox train and they use it in their game to generate objects fast. Usually it's low poly, so you can see the examples. It was not that impressive, but it was actually good in understanding shapes and it was working for Roblox. Actually, early this year, they announced it like this Cube parts, and that was something because you not only generate the object, but you also basically name parts that you want to extract, and it does it. And inside the Roblox there's another layer can actually set the interaction or like movements and stuff, and that was actually looking quite interesting. But at that time that was not released until this day. Actually, this month is heaven for those who like local stuff, so we can see a few examples on their website. For us it's very important that we do have code. Okay, so we're gonna go to the code and here's what we see. So pretty much everything is open, released and published, so you can actually install it right now. Let's build the bad news first and then the good news. The downside is that it still requires quite a lot of memory. They recommend 24 gigabytes with fast inference if you run it, or 60 gigabyte. I guess it will be the minimum requirement, which is still high, but again, I think if it goes further, we're gonna see some optimized quantized version, GGUF version, maybe something like that is gonna happen if it become popular. Another thing which is a bit ambiguous is that Roblox clearly announced it as they open source it, but if we take a deep look into the licensing, then they say that it's under the same license as a Cube, which is again the foundation model here, and the same license. And the license right now says that this is research only rail license, and it also confirms here permitted purpose means for academic and research purpose only. So you can definitely play with it, but for commercial use it's absolutely unclear. And again, with Pixel 3D there was same story, there was same license, but they recently updated to MIT license. So I guess something like that might happen. My channel is only about research, so I'm safely moving on to the installation. So how we're gonna install it? I do not have 24 gigabyte VRAM, but I really want to test it. I'm gonna use run pods, basically just a cloud GPU with SSH access. You can do that any other way, or if you have 1490, 1590 NVIDIA GPU, then you can run it locally. I'm gonna show my process. This is not the ad, so you can actually skip to this time code when we're gonna do the installation. Right now I'm gonna quick prepare my run pod. I'm gonna do pod with a 40 gigabyte VRAM just in case. Actually 24 definitely gonna be enough. So here's just so you can see like what settings I used, and ChatGPT actually recommended me to set 50 gigabyte container and persistent storage up to 100 because there's a lot of models to load, and it cost me $0.50 per hour. Not that cheap, but it's fine. And I actually launched it. I'm gonna open my pod through Cursor. You can do that through VS Code and or any other IDE. So how do I do that? There is instruction. You're gonna need to SSH key. So, and there's like instruction how you do that. Quite easy. Then you copy and you add it to your account here. I already did that. I'm gonna skip this part, but you can easily find how to do that. This instruction is at run pod. If you're gonna use anything else, there might be different instruction, but pretty much the same. So my pod is actually running, and here is all the access. I'm gonna shut it down anyway, so I'm showing you all the access key and stuff. What we're gonna need first is that we can copy this SSH command and paste to the PowerShell and just test if it works. If you did everything right, you're gonna see something like this. This means I'm able to connect to it. We can actually start working on it. So here's how I do that. I'm gonna go through it very quick, but since many of you ask very quick overview. So in Cursor or VS Code, you're gonna need this remote SSH extension. This is recommended officially by Runpod, which will allow you to connect and see the folder in very convenient way. I already installed it. Now, easier. So we're gonna go to Cursor. We don't really need an agent because my flow is built around Claude Code. You're gonna press Ctrl-Shift-P. In this menu, type remote SSH and there's connect to host. Let's do that. We're gonna press add new SSH host. Here's my old one that I was testing. So we're gonna just delete it and paste new one. So how did I come up with this one? Is actually pretty simple. Here is all data that you need and the rest you can actually copy from my template, or you can actually ask ChatGPT how to help you with this file. This is always the same user, always the root, and the name, you just give it a name. Okay, I'm gonna save this file and pretty much that's it. Now we actually can connect to our host. So we're gonna Ctrl-Shift-P again, SSH, connect to the host, and now we can see Runpod CubePart. This is exactly how I name it. And wait a little bit, it's connecting. Okay, say yes, we trust this host. Now, here when you see this, you're gonna need to open folder and we're gonna need to open a workspace folder. Here, just type workspace, you can remove that, and just type workspace, you're gonna see workspace, right? Well, pretty much that's it. We are inside the cloud GPU. Well, what's gonna happen next in my small tutorial that you can do with ChatGPT, but here's the trick. We're gonna need to add a new user. We're gonna call him Stefan and add new folder Stefan and add the permission on this folder. Then in that folder, we're gonna install Claude. The new user only needed so we can run Claude with bypass permission. I do that because he will be automatically installing all the thing related to the CubePart and you're gonna see how it works. After I switch to the user and install the Claude, I check the version, it works, and then I need to authorize login into the Claude. It gives you the link, just go by the link in your main browser, then copy the access link, paste it there. It's quite simple. And I already can see Claude in my folder and we're ready to start working. All right, and with Claude, we're gonna actually go fast. I'm gonna just go and copy the link to the CubePart GitHub. And this is what I wanna say. Like I need to install this with all the dependencies and I will actually ask it to run a test after it succeeds. And guys, this approach is a lifesaver for me. In bypass permission mode, it can do the stuff, especially on Cloud GPU, nothing to be worried about because it actually runs on Cloud GPU. And so I just let it go. Yes, it spends some tokens, but I'm on $100 plan and I never faced the limits, no matter how I try. Maybe I'm not using that much, but yeah, tasks like this are absolutely no-brainer for me to do this way. I had to guide it a bit. The first thing that I saw that it's not installing the cube into the workspace. That was a little bit of problem, so I asked it like, can you make sure that you install it in workspace? Why in workspace? Because after you shut it down, everything that is not in workspace will not be saved. Again, that's only relevant to cloud GPUs. If you're installing on your local device, you don't have to worry about all these things. And also advantages of cloud GPUs is that you installing everything from scratch and it works. Again, all the wheels for specific GPU, all the dependencies, requirements, all that stuff. But since you're not gonna see the process, the terminal, how things are installed, it might look sometime that do nothing, but there is a monitor and it will let you know when it's all installed. Because installing PyTorch, CUDA, it can take up to 10-15 minutes, which actually happened to me. Eventually, I have everything installed and the first test was done, and you can see in folder, I already saw the test. And usually in each project like this, there's Gradio UI that you can run. Specifically, I asked it to set me Gradio Live link so I can open it from my end on my computer, even if it's running on Cloud GPU. And that's actually possible. It took me a bit to figure out. I asked it, what do you need from me? So it asked it for the pod ID, which I provided. And then it started to install Gradio. And 5 minutes later, I actually made it work. And here you can see it gave me a link to gradio.live. And boom, here we go. We actually have it up and running. Again, you can do the same thing locally. There is no Comfy UI version, as you might guess. So you can only install it like this. I guess at some point it will be Comfy UI if there will be no mess with the license. And right away I did a simple test. test, and you can see how it works. You add the GLB, you name the parts. So this list is actually editable. I'm gonna explain about the settings a bit from what I learned, but let's run it and see if it works. And yes, hooray, it actually works. Super. Now let's do actual testing, guys. So if you were listening carefully, I also mentioned it can generate 3D, and it does. But we are doing only cube parts because that is more interesting. Cube 3D by itself, again, produce only text to 3D and without texture. In their roadmap, they are about to do texturing and I guess like higher resolution, but so far there is nothing impressive at all. And again, it's not even textured, right? So here's how meshes look like. You can see like quite far from being sharp, and this is what they called high res. Again, the use case of this is mainly in Roblox, the Cube 3D, the foundation model. While CubePart work with any other mesh, there's a trick around it. It's not using the mesh, it's sort of like inspired by mesh. It decoded into a latent 1K space and then do this stuff. Here's why it matters. I actually went to Hunyuan, which is again also free, and I prepared some tests for you guys. So we're gonna start with this one just to see how it actually can separate parts. So this one generated in like 1 million polygons. You can see it's quite detailed. So now we're gonna upload it here and let's run the test. Note that there's only max 8 parts supported, like 2 to 8 part as they say. And here's what the settings do we have. And so I would say playing with the settings not really makes sense because the model was trained in these values. Some of them, like marching cubes log T resolution, supposed to add more resolution in output mesh. But if you're gonna try to tweak it, you're gonna instantly increase the memory consumption. And when I tried to set like it to 9 to increase the amount of polygons, my 48 gigabyte here was not enough. Not to say about 24. Other settings are also recommended to be like that, so you technically can try to increase them, but will significantly increase VRAM consumption. Now, why do I explain all of this again? Latent 1K means that no matter what's your input, it will be resampled and kept in 1K latent space and rebuilt with CubeParts, like if it's a new object inspired by some point clouds. This is the easiest way I can explain this, guys, but it means that it will not keep the original GLB that you provide and just split it. It will recreate based on that model. But here is the result, and in terms of parts, it actually impressed me. Well, this is really impressive for the open source that we get, and you can see that each part is actually named. So let's download it and check it in Blender. Okay, so here are the objects in Blender, and here is our CubePart. And you can see it actually follows the shape quite accurately, but the detail, the amount of details, it's not the same. And it is probably impossible right now to increase the amount of details on the mesh, but the parts are quite logical. And you can see it even export the names to the Blender, which I actually really appreciate. I don't need to guess what is the part 2, right? Like receiver, grip, stock, all of that. Yeah, and there is no texture. It only do the separation, so ignore the texture and ignore the original mesh. Let's do more test and comparison. So I prepared more 3D models, and here's some observation that I noticed. It's quite accurately follow the names that you provide. So here in this example, I provided shoulder armor and wings. And there are no wings from the backside of the model. So you can see the wings and shoulder armor is pretty much the same object twice. And I was like, what? And then I realized it's basically my fault. And I decided just to remove wings and do the generation again. It gave me quite nice result. Just look at this. And the hand is inside, and yeah, it looks so much better. The same way I did more tests, and only in 1 of the 10 it failed understanding some shapes. It was the joystick, by the way, on this parts. Also, there was a scorpion that also failed a little bit, and well, not a little bit, to be honest. Like the head for some reason was not detected at all, and the head was detected on his tail, so it was a bit messy. Not all the parts was misdetected, and also there was some noise in front. There was nothing like that in the original model. But some was extremely good, such as this one. Look how accurate it defined all parts. Very, very nice. And by the way, guys, of course, all this already added to Top 3D AI. So you can go to compare or battle mode into the segmentation. And here you have CubePart, which is already there, along with any other segmentation tool. By the way, there is also Tripo V2 segmentation, the update just from the last week. Also improving the segmentation quite a lot. And here you can compare them side by side on all these 10 tests that I show in the video. Exactly the same model. Before we compare it with some paid tools, let's take a closer look in Blender, and I want to show you one interesting thing. Okay, so here's the Hunyuan model and here's our CubePart. And what I want to show you is that, again, the parts are extracted, understanding what's inside, right? So, for example, neck, again, like there is a neck there, right? So there's a space. It's like it understands that it should be some part going inside and like that. Same thing with the legs, right? You see, like this part is how I would do that naturally, right? Because this is where the leg connects. And this is small but very important detail. If you compare it with Tripo, Tripo does very good job. It keeps all the resolution right. You can see how sharp the model is. Of course, it's a paid one, but you can see the way it separates it. It basically cut it right on the geometry, right? Like this. It's not a separate part, right? It's just a part of a part. It's like a cut part. And here you can see how it disconnects the leg. Yeah, Tripo, by the way, of course, support way more parts than CubeMesh. Like you can even go 15 plus parts. So does Rodin, for example. You can split into the unlimited amount of parts. But it is quite cool that open source model is doing something really nice compared to them, right? Even this small thing, understanding parts accurately, I don't know. I'm quite impressed. Just add here a little bit more resolution and it will be extremely useful tool. Here we go with one more example. And again, the light, the engine, right? Look how interesting it extracts it, right? All the tubes here are consist. I don't know, the seat was detected a little bit wrong, right? I think this is for fuel. Small problem here, but otherwise it's okay. And this wheel is better, right? So I guess like the only thing right now is the resolution and that the texture is not baked is quite a problem. It's not really convenient. But again, this open source and it's something that you can run locally on consumer's grade GPU. And in some cases, let's say we do some low poly stuff, it actually outperforms some paid. Let's say here you can see how it separated the legs and here's the item. And there was some problems separating them, right? You can see it like splits one leg into 3 parts, quite inconsistent. And here it even like separated some small part inside, which is funny. And the reason actually why it works so well with parts and understand parts by name is because they do have the largest data set, vocabulary of parts, labelets, and it looks quite significant, like 2 million parts, 500,000 of assets, labeled, named, and stuff. And they also share that data set, which is amazing, and hopefully it will push this evolution even further. But it's not perfect all the time. So for example, in this joystick, I guess maybe like Tripo did like way better job, maybe like too much details. I actually was choosing like balanced, but here, yeah, it failed a little bit like on this area. Now maybe actually I like this one more. There's only 8 part max, right? And here's all the 8 parts used. You can see like these buttons. Well, it's not that bad. Like it just failed like in this moment. I don't know. Like I think the prompt was quite simple, no? This area, but yeah, it failed. So that is all update for today, guys. Gonna keep eye on all the updates. Like and subscribe to not miss any important news related to 3D AI. Always take a look on Top 3D AI. There are all models always available there for comparison as soon as they go live. See you in the next video.